Hello everybody, getting ready to do the 5.2 tune-up lesson to go through the tune-up for 5.2 for SAT Math Level 1. 5.2 tune-up exercises after your lecture, the video or PowerPoint. It is worth 66 points here. If you need the sheet, you need to email me so you can receive the booklet that goes with this course. It is worth 66 points. Number 1, the polynomial x cubed minus 2x squared minus 9x plus 18 is equivalent to which one of these expressions here after this has been factored down. Number 2, I have a word problem here. Resistors R1 and R2 are connected in a parallel electric circuit. The total resistance is this expression here. So you have a complex fraction. You have to solve this complex fraction, which is equivalent to which one of these expressions here. And then number 3, in how many different points does the graph of the function here intersect the x-axis? So you can use a graphing calculator to check yourself or do it analytically by factoring this out. And then number 4, you have this expression up here, this complex fraction. The expression above is equivalent to which one of these? So factor this down to find what is the equivalent expression to that. Number 5, if p of x is a polynomial function and p of 4 equals 0, then which statement is true for this situation here? So you have to kind of do a kind of like it's a deeper kind of question here where you have depth of knowledge, kind of like a situation where you're doing a hypothetical here. Is a polynomial function where p of 4 equals 0, then which statement will be true? So you have to extrapolate from this statement to one of these statements here. So it's a good question. And then number 6, the expression above is equivalent to which one of these? Again, you have to factor this down. And then number 7, the same thing, another complex fraction here. Number 8, we have this polynomial here. If the zeros of function f defined above are represented by r, s, and t, what is the value of the sum of r plus s plus t? So again, it's kind of a depth of knowledge, deeper thinking kind of a question here where you have to think about the format and the structure of polynomials and how you factor them and what your, well, I'm not going to give it away. I'll let you come up with that. And then number 9, the expression above is equivalent to which one of these expressions here? Again, another complex fraction that you have to factor out. Then we go from a table here, several values of x and the corresponding values of for polynomial functions f and g are shown in the table above. Which of the following statements is true? So you go from here, from your statements here that would possibly be relevant to this situation here, and then you have choices here which one of these conditions would be would fit this situation here. A good question. 4 points for that. Number 11, which equation represents the graph for this graph here is above? So 1, 2, or 3, and then for A. So you have to like kind of understand how higher order polynomials act as a graph by looking at their factored form here. And I'm not going to give it away. The solutions are available on a corrections PowerPoint. Contact me for those. Those are available in the course. If you paid for the course, you have access to those. 12, which of the following functions have zeros? -1, 1, and 4. So again, you have to understand the structure of polynomials to respond to this intelligently. And again, these solutions are available. Contact me for those. And then 13, which of the following is equivalent to the expression above? So again, you have to extrapolate, going from here to this, to these. Which of the following is equivalent to the expression above? So you have to simplify this until you get something like this. So you have to work this out. And then 14, what is the sum of the zeros of function f defined by the equation above? So what is the sum of the zeros of function f defined by the equation above? So what are your sums of your zeros or your x-intercepts? You could use a graphing calculator for that. And then 15, a polynomial function contains the factors of these here. Which of the graphs above could represent the graph of this function? So here are your factors of a poly. So which one of these graphs could represent the function with these factors here? And then again, we have a graph here, 16 through 18. What is the greatest integer value of k for which f of x equals k has exactly 3 real solutions? So if f of x equals k, then which one of these would fit this graph here? 16 and 17, again referring back to that graph. What is the best estimate of the remainder when f of x is divided by x plus 3? So we have to, that's more of an analytical question. Then 18, what is the maximum number of points a circle whose center is at the origin can intersect the graph of y equals f of x? This goes back to the section on circles, on the equations of circles. Get into some grid ends here. We have a complex fraction. What is the solution for k in the equation above? Fill that in your grid end. You get grid end practice here. Again, another complex fraction equation. Then we have a polynomial here. How many zeros of the function f defined by the equation above are located in the interval, in this interval here? So basically you have to find your zeros here, and then how many of them would be in this interval here. Number 4, if x and y are solutions of the equation above and y is greater than x, what is the value of y minus x? So again, grid in your solution here. And then x cubed plus 150 equals 6x squared plus 25x. What is the sum of all values of x that satisfy the equation above? So what is the sum of the values of x that would satisfy this equation? Number 6, in the polynomial function above, k is a non-zero constant. If p of t is divisible by t minus 3, what is the value of k? So we have another one of these k problems here. And that is your tune-up exercise for 5.2. The solutions are available here, the solution PowerPoint, which has all the solutions and the explanations of the problems are available here. Contact me for that. Thank you very much.